Right, sorry for getting started a little late, but thank you for joining us this morning. So the talk this morning is about the business case for cloud management, and I wanted to kind of put some things in perspective, take some things we've seen from some of our customers over the past few years about how they think about the value they get out of cloud and also the choice that they face when they decide, do I go with a cloud management solution or not, and if so, which one? And so that's kind of how I'm going to structure this, and it will take some of the themes that you saw in Michael's keynote, if you were able to see that this morning, and apply them in a little bit more depth. So hopefully that will be useful. So let me give you a brief overview of the roadmap here, or let's see if I have this guy on, or we're going to use this for right now. So what I wanted to kind of first jump into a little bit was overview of benefits of cloud. So, this was kind of to set the stage for why cloud management. You need a little bit understand why people are moving to the cloud and also understand a bit about what kind of challenges people face there. So there's some unique things that the cloud offers, but also some unique things that the cloud requires that you do to enable to get many of those benefits. And that's a lot about what cloud management is. So we'll spend a couple of minutes first going through what are some of those benefits, how do they manifest themselves, and then step back and say, so therefore, what are some of the challenges we need to solve, and what are some ways we can solve them? So it's kind of the view of the first portion of the talk. We'll go into then why cloud management itself, and end with a framework for how you can think about measuring the benefits of cloud management. So the idea here is taking some of the proof of concept work that some of our customers have done, and to also go in and look at what does a rigorous analysis look like, what does a more basic analysis look like, what are some benchmarks and numbers you might be able to use, and also preview some reports and white papers that we have coming out soon on this topic. Just to get a broad sense of the audience, are you guys mostly, anyone here who's a RightScale customer, or is it prospects, partners, general? What do we have? Let's raise your hand if you're a prospect in the audience. Okay, excellent. And partners in the audience? We've got a few of those. And do we have any RightScale customers in the audience? Awesome. So we have all of the above, so I'll tailor it so that it's hopefully useful for everyone. So basically, ton of benefits in terms of agility, cost, many other things, but almost all of those benefits require significant organizational and process change from what came before, and so you can look at a lot of those benefits from a half-empty, half-full kind of view, depending on what you're able to actually build out in your organization. You can jump on the cloud and use a credit card and spin up servers, and you'll achieve some of those benefits right away, but you're going to quickly run into some of the other challenges that are also new in that model, just like any sort of model that has pretty profound changes that we may have seen in the past with the move to virtualization or the move to client-server paradigms. So to go over a little bit of the benefits, I'm going to take the generic NIST definition of cloud computing and run through these in a little more depth and describe them in a way that RightScale sees them. So the first piece of cloud computing, and this is also pretty general to virtualization as a whole, is that it's a pooled environment, it's a shared environment, and it's a multi-tenant environment. So that's one core piece. It drives a ton of benefits that you get out of it in terms of cost savings and utilization, but it also has some unique challenges that we're going to talk about there. The second one is what you can think of as a delivery model. So at RightScale, we define cloud as a network and API-based set of infrastructure. And so tons of benefits there in terms of being able to access that from all over the world, access that on lots of devices, have people who can, in external organizations, third parties, consultants, access your applications, managed services organizations, tons of benefits that you can achieve from that. Also lots of risks and things you need to think about with your applications being network and API accessible to the world as well. The third one that we're going to talk about is essentially the service model, and this is one that a lot of people focus on for cloud. So this is the typical idea of self-service. I can go on and I can press a button and start something up. And like many things that are easy to start or easy to use, they can also be easy to abuse, and you don't always turn them off, all sorts of things like that. You can think of electricity a bit like this, is that it can be very hard to actually track what's going on, and can be hard to make sure that you're using it in an efficient way. So again, two sides to the same coin here, and so we're going to talk a bit about what is the benefit and what is the cost of that. Fourth one here is another holy grail that people look to cloud for. So this is the elastic resource model. This is kind of this idea of auto-scaling, the fact that, you know, I have a retail application or I have some sort of batch processing application that will scale with needs, whether it be internal or external demand, and you know, a very kind of traditional view of cloud. It requires a ton of work to make that work flawlessly and to make that work in an automated way. RightScale focuses a lot on that, but this is something that I think a lot of people, you know, set out as one of their goals when they start cloud, and it's something that typically takes them a while to achieve over time. And we'll speak a bit about why that is. And the last one is also pretty fundamental change in IT, and Michael spoke about this when he was talking about on-demand before. The idea here is that the billing model for cloud is totally different. Right, so Lydia Leong at Gartner talks about how cloud has essentially created a rate card for IT, which means all of a sudden things that were all just internally priced in the past are now there's a public rate card that Amazon and Rackspace and Google and Microsoft set out in the world that says, here's what it costs. And people within your organization will be comparing against that rate card and able to understand, so how much are you marking up and what's going on? And also, this is something that's pay-per-use. So it's moving from a CapEx model to an OpEx model. For some organizations, that's a huge benefit. Others, it may not be. And moving to that sort of a model in IT financial planning and resource planning can be very significant. Particularly when you look at the intricacies of the pricing model that exist on the cloud. So that's where we're going to start. We're going to talk a little bit about these benefits, and then we're going to go through what is the analog to them in terms of what are some of the challenges that people see as they're adopting cloud and how cloud management addresses those. So first idea here, you can kind of think about, you know, maybe a virtualized data center or even a mainframe environment as a purpose-built system, typically a single tenant environment. It may serve tenants within an organization, but typically it's all controlled by one central org. It's typically also fairly low density in terms of what you're putting on it, unless it's something that's extraordinarily highly virtualized. When you move to cloud, it's fundamentally a different thing, right? It's something that's been built from modular building blocks rather than one purpose-built system as a whole, but it's meant to be essentially pieced together like Legos. And so what that means in terms of some of the benefits you get out of it is that you can actually orchestrate a bunch of these different pieces into higher level services. So you see Amazon doing this and OpenStack doing this in the way that they piece together a storage system plus a queue system plus a compute system into something like Elastic MapReduce, which actually is then a hosted Hadoop service. So it's fundamentally different than this first way of doing it. It's also multi-tenant and high density here. So what that means is you may not know your neighbors. Your neighbors actually may matter in terms of your performance. And those machines are being put into high utilization. So this is what drives the cost efficiencies of cloud. It's also what sometimes drives some of the challenges that people see and that we see when they're looking at, you know, like, I need to spin up a couple of VMs to find the one that I really like because they don't all behave exactly the same. The second major piece of cloud in the NIST definition is a network and API accessible service. And so, you know, and we come across this with many prospects and customers that we talk to. Many of them come with this idea of, well, my data center has always been isolated. It has, firewalls. It's completely gapped to the outside world, and we like it that way. We built it that way, and we don't want any sort of security breaches or other people talking to it. And we get into talking with them, and we're like, well, so how are you supporting mobile devices, and how do you support contractors, and how do you support all the other things that are coming in to the world of new applications that are being built, and it starts to change things. And so cloud is built, again, in a fundamentally different way. It's built for network access. In fact, that's kind of the fundamental definition of cloud, is that it is accessed by the network. It's also, importantly, programmatic and extensible. So it's driven by APIs. This is a reason why RightScale chooses the clouds that we integrate with, and that is because if someone does not have a robust set of APIs, we can't do anything with it. We can't send them messages. We can't give them a phone call to make things happen. We need things that happen by code. So this is essentially driving the infrastructure as code. And so this is another huge benefit of cloud, is that all of a sudden you can have applications which are exposed and able to be accessed globally from lots of devices that are also programmatic. But as we'll see further on, there's some challenges to that too that come up. Third major piece is an on-demand self-service model. So traditional IT felt a little bit more like the full-service lane at the gas station. The focus was, well, you can, I guess, argue this point, but the focus was on service level, and that we had a specific service level that we were going to provide, and we were going to control that service level. We're going to control exactly what went into it, the procurement of everything. It was going to be closely managed. Cloud takes a totally different point of view. Cloud takes the point of view of, most typically, particularly public cloud, but in many cases, many of the private cloud implementations we see are also moving in this model, this idea of a self-checkout, this idea that somebody can go up and ring up their own things, and as long as you have a robust enough self-checkout system, people should be able to handle that themselves. And although that may require some additional thought and some additional work on behalf of end users, that is valuable because the focus here is on weight and throughput rather than a focus on service level, right? The focus is not on, is somebody putting groceries in the bag for me? The focus is on, I can actually skip the line. The focus is on, I can get out of the store faster. And this is also tends to be a more decentralized model as it currently stands. Certainly you can have a self-checkout system that is built centrally and maintained centrally. But this is, again, one of the fundamental challenges that you see, is that how do you balance this tension of people wanting the ability to access everything at their fingertips in a self-service fashion and being able to, in some way, control that centrally. It tends to be the thing that people come to us with questions about. The fourth of the main benefits is elastic scale. So this is, again, one of these core cloud benefits. Traditional data centers tend to be capacity bound. You have a decision point every time you want to add a server or a rack or expand that data center or add a new hosting provider. They tend to be sized to the peaks of the load. So I was speaking last night with one of our customers who does gift card processing, and he was explaining, we look like a traditional financial services business, but in reality, 80% of our business happens in November and December. It's when everyone buys gift cards. It's when everyone redeems gift cards. And he's like, in the past, we've actually had to size for the peak there. We have data centers that are built to handle that peak, and it doesn't make a lot of sense. So this is not just a mobile or social app that we're talking about here, but actually a lot of businesses have certain parts of their application, certain parts of the service within that application, which can vary, whether it be daily, whether it be weekly, whether it be throughout the year, or some other seasonal fashion. And so that can be very important. Like another financial service example, folks who run a mobile app that use RightScale to essentially report on stock price sees a spike between 3 and 5 p.m. in the afternoon as people check closing prices on the stock market. And it's something that happens very predictably throughout the day, and they want to be able to use the cloud to essentially have two pieces there. They're particularly interested on size to current use, so this idea that at any time I don't need to over-provision resources and spend money, but I can actually have things that are appropriately being used. It also gives you this idea, and I put it here not necessarily in scare quotes, but in single quotes, infinitely scalable. So the idea, at least of the public cloud, is that it can be infinitely scalable. There are some caveats to this. It is certainly not infinitely scalable. It sometimes runs into capacity constraints, but typically those are short-lived and will be responded to quickly. But that does happen for people who are spinning up many hundreds or thousands of VMs at a time. The last main piece, and this is, I think, the one that perhaps has taken people most by surprise, because it's also the one that's been the last to develop in public cloud, is this idea of metered pay-per-use. So at the very beginning, this was one of the core benefits of what public cloud providers talk about. This idea that it's going to run on a meter, just like my electric meter that runs outside my house, and I'm going to go get a bill every month that says, here's what you spent over the last month, and I'm going to check it, and it, based on some tiering, gives me a bill. So that's kind of the new model. The old model, however, was a CapEx and maintenance model, which we were typically associated with building out data centers and then potentially provisioning additional hardware to them. And it was allocation based on forecast. So the idea here is that my forecasting ability for my capacity and utilization was the most important thing I could do, and therefore I would build out the appropriate size of a data center to meet that. In this new model, this idea is that I have an OpEx model. It's based on usage. I pay for what I use. I don't pay for what I don't use. Sounds amazing. Is amazing for many people. One of the biggest benefits for cloud, particularly for startups. However, as you can imagine, this transition maybe hasn't been quite as smooth as this story would suggest. It's not just as simple as we move from a CapEx to an OpEx model. We move from not having to, from having to plan very significantly to all of a sudden not having to plan at all. So what we find sometimes at RightScale is this idea a bit of the accidental tourist in the cloud that's, I can just sign up, launch some servers, kick back, and it works. And in many ways, that's true. What they may not notice is that if those cloud servers go down, it may break. If you forget to turn it off, you'll still get charged. All sorts of things which are some gotchas that you have to think about. And this is really where cloud management fits in here in terms of being able to take the benefits of cloud and actually realize them in a way that is a little bit more sustainable than perhaps what some of the marketing focus has been up to now. So I'm going to contrast that same list of 5 with 5 challenges then that are related to the same thing, to the same production model. So before we had this idea of pooled multi-tenant resources, and so the challenge that we get from that then is consistency primarily, consistency and reliability. Does my VM behave the same when my neighbor is different? If somebody else who's also sharing the CPU is doing some sort of IO-intensive task, is it going to be as reliable in this model as if I built it myself? So that's something that we have to think about and we have to plan for. A second one is the delivery model. So we talked about the network and API-based computing, and what we get here is some concerns about security. How do we think then about security in this paradigm where things are built to traverse typically the public internet? That's changing somewhat. There are a lot more options now than there were a couple years ago. But still, most of the fundamental assumptions in public clouds, and to a certain extent private clouds, is that things are broadly accessible across networks. And so you are responsible for closing those doors and plugging those holes and making sure that the network itself is secure to whatever the needs are for your applications. The third one here is kind of the service model. This goes back to our self-service checkout idea. The challenge there is that it's a waste and inefficiency. It's so easy to consume, and that you may not even pay attention to the fact that you need to turn off these services when you're done. We see this at RightScale all the time, and we've had to even sometimes build some of our own internal tools to manage this, which is, well, I spun up a server, what happened, and then maybe I actually remembered to turn it off when I was done. Did I turn off the attached storage to it? Did I remove all of the snapshots which I took of the database? Did I remove the IP addresses? All of those things actually charge money by the hour or by the day or by the month. And how do I remember to do that? And how do you make sure in a self-service model to provision that you can also think about self-service deprovisioning at the same time? The fourth piece is automation. So here we talked about elasticity and elastic scale. The question is, how do I actually achieve that in a way that is instantaneous, right? The whole point of elasticity is that it needs to respond at the same time as demand is changing. If I have to go in and manually create elasticity, it's only somewhat elastic in many ways. And so there are ways to get around this without automation, but typically the way that we see it being addressed most successfully is a significant amount of automation and a significant amount of integration of systems. This takes work to integrate things like a monitoring system, an alerting system, a configuration management system, and a lot of other pieces. And that's one of the things that cloud management addresses. Is how do you actually automate all of these components so that you can spin up things without manual intervention. And the last one goes back to our idea of metered on-demand payment. And here the idea is in this model where I just pay with a credit card and I get a bill every month, what if I don't want to be surprised by my bill? What if I don't want to have my cell phone bill or my cable bill all of a sudden double or triple every month, which is something that we see a lot of customers have the challenge of, which is my cloud bill is going up and I don't know why and I don't know how to control it and I don't know what to expect and my CFO is going to kill me. And so the question becomes, what do we do about that? So how do we plan and track some of those pieces? So, to dive into these a little bit more, first one is this idea of pooled resources. And this is kind of the view of a hotel, I think is maybe the closest analogy, particularly to the public cloud, but you also see this on the private cloud where you have multiple business units or multiple applications sharing resources. The whole point here is that a hotel wants to fill the available rooms, right? Utilization is what makes a hotel a business model that works. Utilization is what makes cloud a business model that works. The challenge with that is that you don't know what was the person who was in here before doing. Who next door, am I hearing noise? Is it loud? Are they smoking? What's going on? And so we have questions about consistent performance and reliability. So are the resources that I'm using right now affected by other people? And can I measure that? And can I benchmark that? And can I throw away the ones which maybe are the bad apples, which certainly exists? And then the second one is a question of consistent utilization, which is I also want to utilize this very, consistently and very well. And so in order for me to think that cloud is a valuable business model, I need to have utilization which matches my expectations on these resources. So it's very much a performance question on the cloud, which is how do I measure these things and how do I actually then take actions which are in some way able to rectify any problems I may have in terms of performance or reliability or in terms of my own utilization of those resources. The second one here around network and API access and where we typically see the biggest challenge is first around security and people treat the cloud, particularly public cloud, but also private clouds, sometimes a little bit too much like their own data centers and assume that all of these things are taken care of for them. So there's been some reports recently about the number of S3 buckets that were left public when they probably weren't supposed to be. And the number was somewhere in the range of 4 or 5 million of those were just open file folders online that you could essentially troll and find all that information. And they sampled 40,000 of these and found all sorts of information, like competitive documents, product roadmaps, passwords, all sorts of things. And so the idea here is that security in many ways becomes a lot more of your responsibility in the cloud than certainly it is in a managed hosting environment, and that you need to treat it a bit more like your own data center environment in terms of how much thought you put into the security of those resources, how you configure the networks, what types of virtual networking you use. So the idea here is you can actually do close to everything that you can in your own data center in the public cloud from a networking and security perspective. You just have to pay attention to it, and you have to know how to manage it, right? The second one is around heterogeneous APIs and behaviors. What we mean here is the cloud also has allowed us, by virtue of having networked resources, I can all of a sudden utilize a ton of vendors that I may never have been able to use before. Or I may want to use them for geographic availability, for data residency requirements, all sorts of reasons. And the question is, how do I utilize all those different vendors on this network in a way that is consistent and doesn't take up too much of my time, so that it's actually valuable to me? And so this is the, this idea of a multi-cloud API and a multi-cloud abstraction layer. And what we find here is that although there is a lot of talk about APIs being compatible to a certain extent, or certain APIs being compatible, the reality is that underlying that, the behaviors of those APIs are vastly different by cloud. Like how a network works in one cloud or another, in one provider or another, is very different, even if you can write the same API call to them. And the same thing for storage in particular as well, that those things do not behave the same, do not behave consistently, and that is something that we spend a lot of time at RightScale trying to figure out and trying to optimize for our customers, is that when I attach a volume, when I assign a security group, does it look and feel the same across clouds, and how do I make that the same expected behavior? Because if you want to get to a model, for instance, of self-service, you need to have people expecting the same behaviors if you're using multiple regions of the same provider, or if you're using multiple providers of public and private cloud, something like that. How do I get people who are trying to spin up the same environment on my private cloud and my public cloud to essentially have a similar experience where they don't have to understand all of the architecture below, where they can actually say, what I want is this type of application deployment, and you go take care, you system go take care of all the work for me. So it introduces some extra work there. The third main piece is around on-demand self-service. So simple, flexible ordering is the idea here. How do I just drive up? How do I, access a menu? Seems simple, seems easy, but as with any sort of ordering system, there's a lot of merchandising and procurement that goes on behind the scenes. There's someone has to go and actually hand pick, what do I launch? What do I use? What are my developers going to be able to access? What should they access? Do I control that or not? Is it a free-for-all? Some people would push the responsibility onto the developers. Others would prefer to give them a predefined set of configurations, for instance, of virtual machines, which they can use. There's a lot of work that goes into actually building that. And the corollary to this, and this is something that maybe the drive-through analogy doesn't pick up as well, is how do I deprovision these resources? It's so easy for me to go through this drive-through 50 times a day. I can go into RightScale and spin up 100 servers. How do I ensure that those 100 servers are actually being used in a way that's efficient over time? The fourth kind of main challenge that we talk about with cloud management is elastic scale. So we have this idea of, I have an application. I want it to just magically stretch when demand changes. The reality behind that is many existing applications require some architectural rework to make that happen. It's not typically just a switch that you flip or an image that you launch on another cloud. It takes some effort. Depends on the application, but this is highly dependent on your own application portfolio and your own, I guess, code writing abilities and skills in your organization in terms of, were these applications ever built for this sort of a model? Because if they weren't, you really need to dig in and understand, will they actually work in something like a public or private cloud where this is supposed to elastically scale? The second piece of this is dynamic configuration is virtually required to make this sort of auto-scaling or elastic scaling work. And this dynamic configuration can take lots of different forms. It could be, I can just easily create new images very fast. It could be I use a dynamic configuration system like Chef or Puppet. It could be everything is scripted out with Bash or PowerShell. There are lots of tools that can get you there. But the idea is that if everything is baked into an image and you can't do something with that fast, it's hard to spin up more machines that all know, within that deployment what's going on. And so this is another thing that RightScale has focused a lot on in our product, and something which is a constant challenge that we see in organizations on the cloud, where typically it takes them maybe 6 months, a year, or even 2 years of using cloud resources to get to the point where I actually have this idea of auto-scaling. Because many of them have a system that maybe wasn't built on dynamic configuration to begin with. And so that's something that will be important to consider as you think about which applications work. And then the last piece here is that, obviously to make something stretch and expand elastically requires you to know when it's supposed to expand and what are the rules behind that expansion or contraction. And so having an integrated system that works between the monitoring system, it could be Amazon CloudWatch, it could be Rackspace Cloud Monitoring, it could be your Nagios system, it could be RightScale's Collect DBase system, and the orchestration tool that actually runs the auto-scaling and the dynamic configuration that knows which configuration you're spinning up is really important. So this is where an integrated tool set is required. And so whether you buy that or build it is what's going to be required to make this happen. And so that's another piece where cloud management has traditionally played a pretty significant role. And the last of the 5 is around this metered pay-per-use idea. So budgeting chargeback purchase options, the idea here is all of a sudden, I can charge with a credit card, I get surprising bills at the end of the month. How do I know what my budget 1 year out is supposed to be? How do I charge back for who used that? I have everything on one bill, and how do I allocate that bill to multiple people? And then how do I actually choose different purchase options? So this is a little bit more esoteric, but many of the cloud providers these days have the ability to either pre-buy in bulk, this idea of reserved instances on Amazon, or to use on demand. How do I make those choices? And so this all requires an understanding of your utilization at a pretty detailed level to make those choices. It's not even just how many cores or VMs do I need over the next year, but it's of which size and in which places, and literally within which zones, and I'm going to have to make essentially buy options on those machines ahead of time if I want to buy into lower rates. That takes a lot of work. I know internally, the first time we did it, it took us a month. It took us a month to decide how many of these reserved instances should we buy as RightScale. And our CFO was like, it should never take that long again. We need to find some ways to make this better. And so that's another place we've been working a lot on that. So to I'll summarize a little bit of then why cloud management. So we talked a little bit there about here are the benefits of cloud, the associated challenges that come from those same benefits. How do I make use of cloud and those benefits in a way that is not totally disruptive to my organization? Disruptive in a bad way, I should say. It will be somewhat disruptive to your organization no matter what, but the idea is how do I fit it into a model that's actually can coexist with finance, that can coexist with my rules in terms of information security and other things. And so cloud management addresses a bunch of those pieces. So in terms of our view of cloud management, let me add all of these together. It kind of talks to a bunch of these pieces that we just talked about. So it's a framework of tools. It's helping you solve a bunch of the challenges that are presented from the very benefits of cloud. And so those are consistency and reliability of a shared commodity resource. The whole point of cloud is that I can drive great cost efficiency and utilization from shared resources. The challenge is consistency and reliability. How do I get that? Secure access. So the idea here is, again, how do I make sure that in a world that is by default, typically by default open to everyone and public, that I can actually secure that in a way which is consistent with what people expect and with what I expect. How do I enable self-service? This is, again, why many people are out there buying cloud to begin with, is I want to be able to swipe a card and go with it. And so how do I create an approved menu? Elastic and instantaneous scalability, we talked a lot about this one, which is I need an integrated system that will automate it such that I can get elasticity. It's a pretty important thing for many people. It may not be the sort of thing that you're able to achieve right off the bat, but that is something that cloud management can actually give you pretty quickly without having to go and piece together your own tool set to do this. And then the last piece here is usage transparency and optimization, and this is a place that you probably have seen a lot of new startups and entrants in the market working on these problems, and we at RightScale are also working on these problems at the moment too, with Plan for Cloud as kind of our first entry into that. We have a number of other reporting services that deal with this. This idea of how do I know what I'm spending, who should be charged for it, and can I spend less, which is what many people are asking. So I won't run through this list, but this gives you then a sense of what is the tool set then from not from an abstract standpoint, but from an actual, like, what are the things that I may need to actually make that work. And so you typically will need some sort of resource manager. Many of the clouds provide that themselves, actually, right? You can go on, you can launch and terminate virtual machines and add storage, do all sorts of things. RightScale also does this at a macro level and also provides you this idea of deployments which help you group them. You have some governance requirements which are pretty similar to typical governance requirements across all types of software and infrastructure. You have a set of configuration requirements which become important particularly if you want to do any sort of automation. This ability to have some sort of service catalog to understand is what someone's running charging them somewhat extra, like are the licenses all in place, all sorts of things there that become important if you want to enable self-service. And then lastly with automation, this idea of how do I know what's going on, how do I optimize it, how is the performance actually working properly. So this is kind of the tool set. The important thing is not any of these tools in particular, but the idea that this is kind of what we see as a comprehensive tool set for cloud management. And the reality is all of these things can be picked and pieced together separately. You could buy something that has it all together. RightScale touches on a vast majority of these. In some cases, we have very strong offerings. In some cases, we have lighter offerings, which we're building out. But the idea is that there are multiple ways to actually get this tool set. The question is, if you want to get many of those benefits that we described earlier, you're probably at some point going to need most of these, at least in any organization of a size where you're running, let's say, 20 or 30 or more virtual machines. You can manage this maybe less rigorously if you're running a very small environment. The other main piece about cloud management, just as an idea, is that it is delivered as a platform. So as we just discussed, you can piece all those things together. The question is, would you like to piece those together, or would you like it kind of delivered as a service? We obviously have the perspective of delivering it as a service is kind of what we do, and what we believe in is that a lot of that, a lot of the work comes in the integration, like many things in IT, and that we think that by hosting it and abstracting it for our customers, they're able to get a better service level, a more reliable service level, and actually keep up with the speed of innovation. The biggest problem that we see people having out there in the market that build their own tools to do this is Amazon comes out with new service X, Rackspace adds new region Y, OpenStack becomes a big deal. How do I support that? Like, there is an immense amount of maintenance required to make all of these tools expand with the expanding cloud offerings that are out there, and it can be hard to keep up. Even as RightScale, it can be hard to keep up, and it's certainly hard to keep up within each of these organizations with the underlying infrastructure. So what does this mean for your business? Basic idea is you can combat complexity. Cloud management allows you to kind of keep things organized. It allows you to respond quickly to meet the market demands, this idea of auto-scaling. It allows you to spend a lot less time firefighting, which is something that sucks in the resources of many organizations. And so having this ability to do auto-scaling, alerting, all sorts of things, like all of a sudden I can tell what's wrong and know exactly where the fire is. I may still have to put it out, but at least I didn't have to spend 10 minutes responding to it. I can keep tabs on what's happening. I have this mission control center. I can see what's going on. It gives me a framework and other people in my organization a framework to see the same information, which can be extraordinarily valuable in terms of what is happening in my environment. It allows me to move around if I want to. We hear from lots of people who say, I don't really want to go through the experience that I have been going through over the past 5 to 10 years of being held to the fire by some of my vendors. I would like the ability a little bit more to have some negotiating leverage, to use innovative services that may be provided by different vendors in the market. This is something that's evolving so fast that betting on one horse right now, for some people, is a great idea and others a terrible idea. And so depending on your organization, you may find this a compelling argument. And then the last one is kind of this idea of focusing on core competencies. Very few people would probably raise their hand and say that building a cloud management system to do all these things is the core competency of their business. And so the question, therefore, becomes, how do you essentially get all the benefits we talked about without having to spend all the time figuring this out? So those are the major pieces of cloud management overall. So I wanted to give you guys a little sense of a measurement framework. And it's a little hard to see this, but this is people doing some motion capture for video games of how can you actually think about what value cloud management provides, right? It's an abstract idea. It's something that people ask all the time of us. And it's a little bit hard because what we talked about was lots of things that are very interconnected, very complicated. And the question always becomes, what's the alternative you're comparing cloud management to? And so I'll give you a little bit of a sense of how one of our customers went through this. I won't suggest that necessarily it's the same process you'll want to go through, but at least it'll provide you some information that might spur some ideas on how to think about it. So the first thing that I thought was really interesting from this customer, a major pharmaceutical company, Fortune 500, they were like, we're going to be moving to the cloud over the next 2 years, and we need to tell our organization what to expect, what tools that they're going to need, and also why is this valuable for us. And so they evaluated RightScale as a system to manage multiple clouds, one, and then also to administer even single clouds in a way that was more efficient. So the first thing that they did was figure out, what do they want out of this whole thing? So as we talked about some of those benefits and challenges, some of them may have rung true to you and some of them may have not. And so with many of these organizations, you can kind of group them into a couple of major categories here, but most people are trying to get a few of these things at least. So they were really interested on overhead efficiency was one major piece of it, the speed of provisioning, and also portability. Those were their 3 things that they really cared about as an organization. Other people really care about, I just don't want to have outages. I need to be able to have 4 nines of uptime in the cloud. How do I do that? Some other people are like, I want to integrate with all these existing processes I have. I have compliance processes, I have internal and external ones, and I want to be able to meet those. So you may have all sorts of different success criteria, and the question becomes, how do you want to optimize for that? So I'll skip over this slide and talk a little bit about, again, this is where they saw the value in cloud management that they were trying to test. They were like, this is our hypothesis that we want to test. Can we validate or invalidate this hypothesis? Can we get a unified administration console? Can we achieve data portability? And can we abstract images across clouds? Some very specific things that they were interested in that were relevant to their business. And this was their testing case that they were looking for in terms of success criteria. They were like, we want to reduce certain costs when migrating across providers. So a cost avoidance in terms of development time, a cost avoidance in terms of administrator time, and a flexibility of the business to do that, and also a cycle time reduction. So how long would it actually take us? There's two things. One, which is like, what am I paying people? But the second is like, if a business says that I need to do this in 3 days, can I even do it in that amount of time? What is the cycle time that's required? And the second was a reduced overhead cost for general system administration tasks. So I'm going to need to monitor all of these things. What do I need to do? They also had certain hypotheses around productivity and cost reduction there that they were trying to achieve. So then we move on to kind of the second piece of the framework, which is how do I apply some benchmarks to that? So how do I understand, based on my criteria, what to expect? Can I measure it at all? So I'll give you some sense of how we think about it internally and also how they thought about it. So one piece was, this is kind of the pie of IT spend generally on the left side, which is broken out across a ton of different things. You notice software development gets traditionally, particularly in large IT shops, a very small portion of the total IT spend. And half of IT spend actually goes towards managing existing systems, particularly incident response, and just managing just lifecycle deployments, updates, patching of what's already running. And so a major piece of this is, how do I save on administrative costs on these things? So one way to think about that is the server to admin ratio, which depending on your organization, how it's configured will differ. But we see things as, there are companies that we talk to that have 20 servers per admin that may be running. For some applications, that may be very appropriate. For others, it may be very inappropriate. All the way down towards some of our marquee customers that are running at extraordinary web scale, that are able to achieve many thousands of virtual machines per administrator that they are actually working on. So they may be running 30,000 virtual machines around the world, and they have a team of 10 or 20 people doing that. And so again, this differs based on your application portfolio, all sorts of things, but one key thing to think about here is, what does that number look like, and what does it mean, and does cloud change this for you, and how does it change it, and also what do you need to do to make sure that cloud actually changes the server to admin ratio in a way that's actually positive rather than negative. So this is the example of essentially the benchmarking information that the pharmaceutical company had put together, and they had come up with a certain set of benchmarks that actually looked at what happens if I port a Hadoop architecture? What goes on? And so they were looking at development time, effort time, and how does it decrease? And so this was one of the experiments that they did. They actually went through, tried it out on their own in their current environment. They tried it out on the cloud provider console themselves, and then they tried it out on RightScale, and we're looking at, here's some of this information. So all of this will be available later for you guys to peruse, but I'll give you a couple of examples there. They have another one on how do I manage multiple instances at a time in a case where a bunch of applications are being developed, and it's necessary to now switch them over, terminate, and relaunch. And then also creating and destroying instances. What does that take in terms of being able to do this across environments and over time across teams? So this is the way that they went about it, an extraordinarily rigorous way, but gives you some information about some of the, depending on your situation, some of the returns you may or may not achieve with cloud management. And the last one to think about here, since I think I've totally run through the entire time, is how do you then compare this to your alternatives? So there's a number of alternatives available. What's your comparison set here? There are cloud provider consoles out there that exist for all of these clouds. They have differing functionality, so you'll want to understand that. You could build your own tools, which some people find valuable, some people find painful. It just depends on your own situation. You could do manual processes. You could choose some sort of system like RightScale. There are a number of options to achieve all of these outcomes. And so the question becomes, what are you trying to compare it to in your situation? And so I'll leave you with kind of one of the results, for instance. This was for the Hadoop application of when they took a look at, we need to be able to move around big data workloads in rapid succession. You know, we do all sorts of pharmaceutical analysis. And for 100 applications, what are the savings we would achieve in terms of development costs? What are the savings we would achieve in terms of labor costs for that suite of applications? They had a whole set of information then that built out on that. But this is the approach. And so at the end, it's kind of like your results will vary, is somewhat of the painful answer to this. But we do see a set of ranges of people getting certain productivity gains and particular use case gains for all of these things. And so what we'll have for you all is a white paper that we're producing with Forrester Research with a different customer actually on cloud management and how it affects their business and what they're able to do, and quantifies those benefits in a certain way. And I'll also make sure that this, with some of the supporting data from this particular proof of concept, is also up on the web, so you can take a look at it and understand a specific example. So caveat that you know depends on your business, but give you some numbers about how to think about, based on all those benefits and challenges that we talked about, exactly what may you expect in the cloud and what may you expect from cloud management if you're adopting it. So I think they're beating down the door to let me in, or to let me out and let the next one in. So I don't know if we have any questions, but see me afterwards. I'll be available if you want to just run up, and I'll let you guys jump out to the next session. All right?